Hi, once again, I'm Noli Pomentil, your lecturer for the part 4 of the mathematics tutorial. And in this video, we are going to talk about statistics and probability and trigonometry. Get your pens and papers and be ready to solve the problems with me. Let's start with our first problem in statistics and probability. Find the geometric mean of 11, 13, and 19. A. 13.95, B. 15.5, C. 14.33, D. 13. First, let's define geometric mean. It is a special type of average where we multiply the numbers together and then take the nth root. Now to find the geometric mean of dataset X, let's use this formula, where n is equal to the number of elements that are multiplied. In this dataset, we have 3 elements, thus n is equal to 3. Now let's solve the problem. We have here cube root of 11 times 13 times 19. Let's multiply the elements. We have 2,717. Now get their cube roots. Since our n is 3, we'll have 13.9539 or approximately 13.95. So our answer in this problem is letter A. Moving on to the second problem. In a club, 3 officers must be selected out of 9 members, each with a different rank. A club member may not be selected as an officer more than once. How many different ways can 4 officers be selected? A. 450, B. 477, C. 504, D. 704. This problem is about counting the possible number of scenarios, or let's say number of permutation. By the way, permutation is the act of arranging objects where order is important. We will use this formula of permutation to solve the problem, where n is the number of given objects and r is the number of objects to be arranged. Since we have 9 members involved, our n is equal to 9, and we are asked to select 3 officers, thus r will be 3. Now let's use the given to solve the problem. We have here 9 factorial over 9 minus 3 factorial, which is equivalent to 9 times 8 times 7 times 6 times 5 and so on, over 9 minus 3 is 6, so we'll have 6 times 5 times 4 times 3 and so on. As you can notice, we can cancel 6 below, so what will remain is 9 times 8 times 7, and our answer is 504. Our answer in this problem is letter C. For our third problem, Simon has 12 different sci-fi books and will randomly select 4 of these books to donate to charity. How many different possible ways can he select 4 books? A. 456, B. 470, C. 495, D. 500. This time, we have a combination problem which is a little similar to permutation, but the order here is not important, so selecting could be random. We'll use the combination formula to solve this problem, where n is the number of given objects while r is the number of objects to be selected. The problem states that Simon has 12 books and will randomly give 4 books. Thus, n is 12 and r is 4. Let's use the given and substitute the formula. We'll have 12 factorial over 4 factorial times 12 minus 4 factorial. Since 12 minus 4 is 8, we could directly eliminate numbers from 8 below, and what's left are 12 times 11 times 10 times 9, and we'll have 4 factorial as our denominator. We could further simplify this by cancelling out 12 by 4 and 10 by 2. Notice that I didn't divide 9 by 3 since it's just the same with cancelling 3 here. If I divide 9 by 3, we'll have 2, 3 in the numerator, which is just exactly the same with 3 times 11 times 5 times 9 over 3 times 1. We'll have 11 times 5 times 9, which is equivalent to 495. So our answer to this problem is letter C. For our last problem in this topic, in how many different ways can the letters of the word fluorescent be arranged so that the vowels always come together? A. 7,920, B. 19,958,400, C. 483,840, D. 39,916,800. This problem is all about arrangement of letters, and we can use this formula to solve the problem. We are asked to arrange the letters of the word fluorescent, but there is a condition. The vowels should always come together. The first thing that we need to do is to list down and count the numbers of consonants. We have here 1, 2, 3, 4, 5, 6, and 7. And now, let's put all the vowels in one group and assign and count them as one letter. Therefore, from 7 we'll add 1, we have now 8 letters. Since we don't have any repeated consonant letters, we could directly solve 8 factorial. We'll have 40,320. Now let's focus on the vowels. We have here 4 vowels, U, O, E, and E. Thus we'll have 4 factorial. Although we have one repeated letter, which is E, and it's repeated twice, so we'll have a denominator of 2 factorial. We could directly eliminate 2 times 1, and what's left are 4 times 3, so we'll have 12. Now let's multiply 40,220 times 12. The result will be 483,840. So our answer in this problem is letter C. And finally, we're on our last topic, which is all about trigonometry. Let's start with our first trigonometric problem. Which of the following expression is correct? 1. Sine B is equal to cosine D. 2. Sine A is equal to sine E. 3. Cosine B is equal to cosine E. A. 1 only. B. 2 only. C. 1 and 2 only. D. 1 and 3 only. To solve this problem, let me introduce you to the famous SOHCAHTOA. Let me first discuss the parts of a right triangle where we can use the famous formula. We have here a right triangle with angle theta. The side opposite to the angle is known as the opposite, while the side next to the angle is called the adjacent. And the side opposite to the right angle is the hypotenuse, which is also the longest side. Now let's talk about the trigonometric functions. We have 6 trigonometric functions or ratio, but I will only discuss 3, starting from sine, which is equivalent to opposite over hypotenuse, where so is derived. We have cosine, which is equal to adjacent over hypotenuse, where chi is derived, and tangent equal to opposite over adjacent, where TOA came from. Since we already understand how SOHCAHTOA works, we can use this to solve this problem. Let's start with the first expression. Sine B is equivalent to cosine D. Our first triangle has its angle in B, and since the function here is sine, we're going to use SO, and we need to find the opposite, which is 6, and the hypotenuse, which is 10. So we'll have sine is equivalent to 6 over 10, or 3/5. For the second triangle, the angle is at D, and our function is cosine, so we'll use ka. Let's determine the adjacent and hypotenuse. We have here 9 over 15, which is equal to 3/5. Since we have the same result, our first expression is correct. Now you can notice that our option B tells that the correct expression is the second expression only, which is incorrect. Thus, we could eliminate option B. Let's move on to the second expression. Sine A is equivalent to sine E. Our first triangle has its angle at A, and we have a sine function, so we need to find its opposite and hypotenuse. We have here 8 and 10, which is equivalent to 4/5. For the second triangle, the angle is at E, and we also have a sine function, so we need to find its opposite and hypotenuse. We have 9 as the opposite and 15 as the hypotenuse. Therefore, we have 9 over 15, or equivalent to 3/5. As you can see, sine A is not equivalent to sine E. Therefore, the second expression is incorrect. Since the second expression is incorrect, letter C shall be eliminated in the option. Therefore, what's left are A and D. Now let's proceed to the third expression. We have cosine B is equivalent to cosine E. Our first triangle has its angle at B, and now we have cosine function, so we're going to find its adjacent and hypotenuse. Our adjacent here is 8, and the hypotenuse is 10. Therefore, we'll have 8 over 10, which is equivalent to 4/5. The second triangle has its angle at E. We have a cosine function, therefore we also need to find the adjacent and the hypotenuse. We have 12 and 15, so we'll have 12 over 15, which is equivalent to 4/5. Since cosine B is equivalent to cosine A, therefore this expression is correct. We have 2 correct expressions, 1 and 3. Thus, our answer for this problem is letter D. Let's move on to our second problem. Find the value of cosine 7 pi over 6. A. Square root of 3 over 2. B. Negative square root of 3 over 2. C. 1/2. D. Negative 1/2. The function is in radian form, and we could convert it first to degree form using the simple conversion equation. Let's plot 210 degrees in the Cartesian plane. The positive x-axis is equivalent to 0 degrees, positive y-axis is equivalent to 90 degrees, the negative y-axis is equal to 180 degrees, and the negative y-axis is equal to 270 degrees, and one revolution is equal to 360 degrees. 210 degrees is just slightly over 180 degrees, thus it is located at quadrant 3. Now we can create a right triangle. The next thing we need to do is to find the reference angle, which is the angle between the terminal side and the x-axis. Our terminal side is the side that defines the angle, and our x-axis is a negative axis, so we'll have 180 degrees. To find the reference angle, let's subtract 210 by 180, we'll have 30 degrees. Now, 30 degrees is a standard angle, and we could determine its trigonometric value either using the unit circle or the 30-60-90 rule. How does the 30-60-90 rule works? So we have here a right triangle whose two sides are 30 degrees and 60 degrees respectively. The opposite of 30 degrees is equivalent to 1. The opposite of 60 degrees is equivalent to square root of 3, and the opposite of the right angle is equivalent to 2. Now, since we're looking for cosine 30 degrees, we have to determine its adjacent and hypotenuse. So we have our adjacent here, square root of 3, and hypotenuse of 2. But since our adjacent is a negative x-axis, therefore, it will become negative square root of 3 over 2. So our answer for this problem is letter B. For our third problem, simplify sine quantity pi over 6 plus 2 pi. A. Square root of 3 over 2. B. Negative square root of 3 over 2. C. 1/2. D. Negative 1/2. For this problem, we are going to use the sum and difference formula. First, let me convert this into degree form. We have pi over 6 is equivalent to 30 degrees, and 2 pi is equivalent to 1 revolution, which is 360 degrees. Since we're asked to simplify with sine function, we are going to use the sum and difference formula of sine. So we have here our formula. Now, let's simply substitute. We'll have sine quantity 30 degrees plus 360 degrees is equal to sine 30 times cosine 360 plus cosine 30 times sine 360. Now, using the 30-60-90 rule, we're going to determine the value of sine 30 degrees. For sine 30 degrees, we have its opposite 1 and the hypotenuse is 2, so we have 1/2. And for cosine 30 degrees, let's refer to the Cartesian plane. Cosine is equal to x and 360 is an x-axis, thus it is equivalent to 1. For cosine 30 degrees, we're looking for the adjacent and the hypotenuse. Our adjacent here is square root of 3 and the hypotenuse is 2, so we'll have square root of 3 over 2. And for sine 360 degrees, since it is an x-axis and sine is 0 in x-axis, therefore sine 360 is equivalent to 0. Now we have here sine quantity 30 degrees plus 360 degrees is equal to 1/2 times 1 plus square root of 3 over 2 times 0. Square root of 3 over 2 times 0 is 0, so what's left is 1/2 times 1, which is equivalent to 1/2. So our answer for this problem is letter C. For our fourth problem, find the equivalent of cosine squared x minus cotangent squared x. A. Cosine squared x plus sine squared x. B. Tangent squared x minus secant squared x. C. Negative 1. D. 0. This problem tackles trigonometric identities, and since we have square in the problem, probably we're going to use the Pythagorean identities. So we have here the Pythagorean identities. As you can see, 1 plus cotangent squared theta, which is equal to cosecant squared theta, is pretty related and similar to cosecant squared x minus cotangent squared x. Let me first replace theta by x to avoid confusion. Now we can transpose cotangent squared x to the right hand side, and as you can see, we already have an equivalent for cosecant squared x minus cotangent squared x, which is 1. However, 1 is not in the option, but notice that 1 is equivalent to sine squared theta plus cosine squared theta, which is the same with our option A. Thus, our answer in this problem is letter A. Let's read the fifth problem. If sine theta is equal to negative 4/5 and tangent is less than 0, find cosine theta. A. 4/5. B. Negative 4/5, C. Negative 3/5, D. 3/5. Now let me first introduce to you the signs of trigo functions. In each quadrant, the trigonometric function has corresponding signs. For quadrant 1, all trigo functions are positive. For quadrant 2, only sine is positive. And for quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Now, to easily remember the signs, take note that cosine is equal to x. Therefore, if x is positive, cosine is positive. Since in quadrant 1 and 4, x is positive, cosine is also positive. Sine is equivalent to y, therefore it is positive when y is positive. So we have quadrant 1 and 2, and for tangent, it is positive when the x and y axis have the same sign, meaning it is positive in quadrant 1 and 3. This is important to determine the location of the triangle since we are taking the signs of the function into consideration. Now, since sine theta has a negative value, therefore the triangle is found in either quadrant 3 and 4. We still have another condition, tangent is less than 0 or negative, and since tangent is positive in quadrant 3, therefore a triangle shall be drawn in quadrant 4. Now we have the illustration. As you can see, we're missing one value of one side, the adjacent, which is needed to determine cosine theta. To find the missing value of this side, we're going to use the Pythagorean theorem. C squared is equal to A squared plus B squared, where C is the hypotenuse. Since we're looking for one leg, let's manipulate the formula. We'll have C squared minus A squared is equal to B squared. Let's extract the square root. We'll have B is equal to square root of C squared minus A squared. Now let's substitute the given. We'll have B is equal to square root of 5 squared minus 4 squared. 5 times 5 is 25 and 4 squared is 16. 25 minus 16 is equivalent to 9. So what's left is square root of 9. So square root of 9 is positive negative 3. Since our adjacent is in positive x-axis, therefore we'll use positive 3. We have now a value of adjacent, so cosine theta, which is equivalent to adjacent over hypotenuse, is equal to 3 over 5. So our answer for this problem is letter D. Actually, 3, 4, 5 is one of the common Pythagorean triples. Pythagorean triples are a list of 3 numbers that works in the Pythagorean theorem. Being familiar with the common Pythagorean triples is helpful since we'll easily determine the missing value of one side. You don't need to use the Pythagorean theorem to determine the missing side. You just have to remember what value is missing. For example, we have a triangle whose given is 5 and 13. So if we are familiar with the common Pythagorean triples, we'll easily realize that the missing term is 12. No need to solve or compute using the Pythagorean theorem. Moving on to the last and final question in our mathematics review and tutorial, an observer stands 685 meters from the launch pad of a model rocket. As the rocket rises, the observer measures its angle of elevation at a given moment to be 48 degrees. At that moment, which expression shows how to compute the distance from the observer and the rocket? A. 685 over sine 48 degrees, B. 685 over cosine 48 degrees, C. 685 over secant 48 degrees, D. 685 over cosecant 48 degrees. Let us first illustrate the problem. An observer O stands 685 meters from the launch pad, and as the rocket rises, the observer measures its angle of elevation at a given moment to be 48 degrees. Now we have here a triangle with an angle and an adjacent. So we are asked to find the hypotenuse. And since we have an adjacent, therefore we're going to use ka, or cosine is equivalent to adjacent over hypotenuse. We'll have here cosine 48 degrees is equal to 685 over x. X is the missing term, which is the hypotenuse. Now let's cross multiply. Cosine 48 degrees times x is equal to 685. Divide both sides by cosine 48 degrees. We'll have x is equal to 685 over cosine 48 degrees. Since we're only asked to show the expression and how to compute the distance from the observer and the rocket, we'll stop here. Our answer for this problem is letter B. And you've reached the end of this video. I hope you've learned a lot from this lecture, and if you have questions and clarifications, you can message me through my Facebook account or my Gmail account. Thank you for watching, and just a short reminder, it seems impossible until it's done.